We're going to be talking about the law of sines. Now, the law of sines is a handy tool you can use to solve for side lengths or for angles of a triangle that's not a right triangle. Now, in a right triangle, we can use the Pythagorean theorem. We can also use our trigonometric ratios to solve for both the side lengths and for the angles. It doesn't work quite that way with a triangle that's not a right triangle, and that's when the law of sines comes in handy. So the law of sines uses a triangle that's not a right triangle, and I have labeled this triangle according to how the law of sines is usually written. So I have my side lengths, little a, little b, and little c, and I have my angles, capital A, capital B, and capital C. Now the side length c is opposite of my angle capital C. The side length A, little a, is opposite of my capital A, and the side length little b is opposite of my capital B. Now what the law of sines says is that if I take the sine of A over the side length that's opposite, which is little a in this case, that's equal to the sine of B over B, as well as the sine of C, my angle C, over the side length C. So let's take a look at why this is and why the law of sines works. This equation right here, either this, you can take it in two parts too. You could just say the sine of A over A is equal to the sine B over B, and that can help us solve for our side lengths. So let's look at why the law of sines works. So if I have a triangle, that's my same triangle right there, and I want to look at the sine, I want to look at the ratio. So I want to look at some ratios in there, especially if I'm talking about sine. And I can't because I don't have a right triangle. You can actually create a right triangle out of this triangle right here, and you can take C and draw a line that's perpendicular to C, so that will actually give me a right angle. Now this is kind of fake line. When you do this to help you prove a point, it's called an auxiliary line, and it's just a line I'm going to use to help me make a right triangle out of my triangle that's not a right triangle. And I'm going to call this segment from here to here, the length of that segment, I'm going to call it x. So now I can talk about some trigonometric ratios. Let's first look at the sine of A. When we take the sine of something, it's the opposite, it's the ratio, so it's opposite over hypotenuse. And the opposite from here, from my angle A, is x, and the hypotenuse is b. So the sine of A is equal to x over b. Now I can solve for x here by multiplying both sides by b. So I get b times the sine of A is equal to x. Now I can do the same thing with my angle b. So the sine of b equals the opposite over the hypotenuse. The hypotenuse in this case is going to be a. So sine of b is equal to x over a. Now I can solve for x as well. You'll see why I'm doing that in a minute. I multiply both sides by a, and I get a times the sine of b is equal to x. Now I have two values that are equaling x. B times sine of a equals x, as well as a times sine of b equals x. Well, if both of those equal x, I know x has to be the same. So these values have to be equal to each other. So I have b times the sine of a equals a times the sine of b. Now if I divide both of them by b times a, I get closer to my law of sines. So divide this side by b times a, and this side times b times divided by b times a. The b's here make a 1, cancel each other out, and I just have sine of a over a is equal to, the a's cancel each other out and make a 1, sine of b over lowercase b, and I have sine of a over a equaling sine of b over b. That's close to my law of sines. All I need now is the sine of c, over lowercase c. Well, if I can show the sine of c over c is equal to either one of these, since this is equal to this, then I can show all three are equal to each other. So now let's take a look at c. And to do that, we're going to draw a different kind of auxiliary line. So instead of the straight up and down one, we're going to draw it from A. So if we take a look at A and we draw an auxiliary line here, it's perpendicular to my side length A. So I have a new auxiliary line. Now when I look at ratios, I really like them to be standing up on their right angle. It just helps me visualize it a little bit. A lot of books will just leave it like this, but it helps me to visualize it. So I took this triangle and I rotated it so I could have my X standing up here. It's just easier for me to visualize. You don't have to do that. And now I'm going to go ahead and look at my angle B, and I'm going to take the sine of B. So the sine of B is the opposite over hypotenuse. So opposite is x over hypotenuse is c. Sine of B equals x over c. I'm going to solve for x again, multiply both sides by c, and I have c times the sine of B equaling x. I'm going to do the same thing with c. So the sine of c is the opposite, which is x, over the hypotenuse. So sine of c equals x over b. I'm going to solve for x, multiply both sides by b, and I have b times the sine of c is equaling x. Now again, I have two values that equal x, so I can set them equal to each other. So I have b times the sine of c equals c times the sine of b, and I'm going to divide by a special number that's going to make this all happen. I'm going to divide by b times c. B times c. And then what will happen here is our b's will cancel and make a 1, and I'll have sine c over c, and our c's here will cancel, and I will have sine b over b. So I have sine c over c is equal to sine b over b, which remember from the last slide is equal to sine a over a. And that's why the law of sines works. Now let's actually see if we can make it work on one of our problems. So if we're given a problem, given a triangle that's not a right triangle, and we're asked to solve side lengths or angles, one of the tools we can use is the law of sines. So if we're given this triangle, we know our angle A is equaling 60, and I just labeled that as A. It doesn't give me the A in there. I just put a little A to kind of know what was happening there. And I labeled that as A. I labeled this was labeled as 40, and I labeled that as B. And my side length is 20 over here across from the 40. And I just labeled that a B up there. And then A and C I don't know. So I don't know my angle C here, my angle capital C. I don't know my side length C, and I don't know my A. Well, we can use the law of sines, but first we can actually solve one of these without using our law of sines. We can just use that we know 180 degrees are in every triangle. So if we know two angles, we know A and B, we can use the fact that they all add up to 180 to find C. So if we take the total number of angles, which is going to be 180, and we subtract these two, we will get to C. So the measure of angle C equals 180 degrees minus 60 degrees plus 40 degrees. 60 degrees plus 40 degrees is 100, so 180 minus 100 is going to give us 80 degrees. So the measure of angle C is our 80 degrees. So we've already solved one of the things we were asked to without using the law of sines. But now we want to find some lengths. Let's start with A. We want to find the length A. Well, we know the sine of A, that's going to be a number because we know that's 60 degrees. Now we want to see if we can set that equal to a number that we know. So if we look at B, we notice we know angle B, and we also know a side length for B. So if we set it equal to sine B over B, then we know we're going to be able to solve it. If we try to use C, we know the angle C, we know that that's 80 degrees. Let's put that on. But we don't know the side length C. So then we would have both C and A in an equation, and it would be difficult to solve, and we'd have to get more information. But if we use B, we know both of those. We know the side length and we know the angle. So we're going to set sine A over A equal to sine B over B. Now let's substitute the values in that we know. So the sine of 60 degrees, that's our sine of A, over A, we don't know A yet, is equal to the sine of B, which is 40 degrees, so sine of 40 degrees, over the side length B, which is 20. Now, in order to solve this equation, we can actually cross multiply, which means if we take the denominator of this one times the numerator of this, it's equal to the denominator of this one times the numerator of this one. So we have A times the sine of 40 is equal to 20 times the sine of 60. Now, sine of 40 is just a number, and I could do that number right now, but I like to do it all at the end. So I'm just going to divide both sides by the sine of 40, and I'm going to be able to solve for my A. So A is equal to, so divide this side by sine of 40, divide this side by sine of 40. A is equal to 20 sine of 60 divided by sine of 40. Now I can go ahead and plug that in on my calculator. And when I do, I get 26.9. I rounded this to the nearest tenth. That's why I have little wavy lines as my A, as my side length A. Now, if you get kind of a weird number here, or if you get an error, your calculator is probably in radians. You need to switch that to degrees because we're talking about angle measure in degrees in this one. So now we know A, and we also know angle C, and we know the rest of them. The only thing we have left is our C. So let's see if we can solve for that. Now again, we're going to use the law of sines. And we actually have two options now. So we want to know C. I wrote in our known values here. And we want to know what C is. So we have angle B, and we also know the side length B. And we have angle A, and we know the side length A now. But this is an approximate number. And so if I were to use this in my sine of A over side length of A, it would make it less accurate than if I used the known value, the value that they gave me right here. It would just make our side length a little less accurate. So I like to use the given amounts, especially if they have exact amounts. So we're going to use sine B over B and relate it to sine C over C. So sine B over B equals sine C over lowercase c. I'm going to substitute in my values. I know my B is 40 degrees, so sine of 40 degrees over my side length B, which is 20, is equal to the sine of 80 degrees, that's my C, over my side length C. I don't know my side length C, that's what I want to solve for. Again, I'm going to cross multiply. I'm going to take C times 40 degrees, and that's equal to 20 times the sine of 80 degrees. So now I have an equation here. I can solve for that. This is just a number. I can divide both sides by the sine of 40. So I get C is equal to 20 sine of 80 degrees over sine of 40 degrees. I can plug that into my calculator, and I get the approximate value of 30.6 as my side length. 30.6. See, I told you you could do it.